Hello, and welcome to this lesson of our C Programming Foundations tutorial series. I'm Reza, and I'm happy to have you join me on this journey to mastering the C programming language. Alright, let's dive into how functions in C programming handle the info you give them. There are two main styles, call by value and call by reference. Think of it like two different ways of sharing your stuff with the body. First up, call by value. This is like giving a friend a photocopy of your favorite recipe. They can use it, scribble notes on it, whatever, but your original recipe stays safe and unchanged. The function gets a copy of your data, so whatever it does, your original data is safe and unaffected. Then on the flip side, there's call by reference. This one's a bit different. It's like lending your friend your actual handwritten recipe book. Now, anything they change in the book, like adding a pinch more salt to the recipe, happens to your original. Why? Because you're giving them direct access to your actual stuff, not a copy. They're working with the real deal, so any changes they make are for real. In short, with call by value, your data is like, hey, make changes, but keep it to the copy, okay? And with call by reference, it's more, go ahead, make changes, I'm all in. It's all about how you choose to share your data with your functions. Okay, so here's a cool piece of C code that shows how you can change a number's value using a function, but in a slightly sneaky way. First off, we have this function called increment, which, you guessed it, is supposed to add 1 to whatever number you give it. But here's the twist. Instead of giving the function the number directly, you give it the address of where the number is stored in your computer's memory. In the main part of the program, we start with a number. Let's say 5, and we print it out. Then comes the fun part. We call the increment function and hand over the address of our number. That's what ampersand means. Inside the increment function, it uses this address to find our original number and adds 1 to it. It's like giving someone directions to a secret treasure, our number 5. And they go and add a little something to the treasure. After the function does its thing, we print the number again in the main program. It's now 6. This whole thing of passing the address instead of the actual number is a nifty trick in C that lets functions make changes that stick around even after the function is done. It's like having a remote control for your numbers. Let's talk about the increment function in this code. This function is a little piece of programming magic in C that knows how to add 1 to a number, but it doesn't do it in the usual way. Instead of working on the number directly, it works on the number's address, like a GPS coordinate to where the number lives in your computer's memory. Here's how it goes down. When you call increment, you don't just give it a number, you give it the location of the number by using something like %x. This is like saying, hey, don't take my actual number, but here's where you can find it. Once inside the function, it uses this address, the num pointer, to get to the actual number. The magic happens with *num++. This bit of code is like a direct command to increase whatever is at that address by 1. It's not making a copy or messing around, it's changing the original number directly at its source. So, in a nutshell, increment is like a skilled mechanic who tweaks your car's engine, the number directly, rather than just looking at a picture of your car and telling you what might happen if you tweaked it. This function makes real, lasting changes to the original number, all thanks to the power of pointers and addresses in C. Here is a code challenge for you to get more practice. Circle calculator.